Hello folks, we have a problem here about the Poisson distribution, and it regards the number of people entering the William Osler Health Center on any particular day being modeled by a Poisson rate of 5 people per day. We want to find the probability that the number of people entering the intensive care unit on any week is 7 and more than 3 people show up in any 2 consecutive days. So to deal with the first part of the problem, we need to go and look at the different kind of rates there are. We're given a rate in terms of 5 people per day. And you got to understand that this is actually our mean. But our lambda, our occurrences, are occurring in terms of weeks. And that's 7 per week. So what we really need to do is we need to change the mean according around the lambda. So we always need to keep our units equivalent. Otherwise it will be like comparing apples to oranges. So respectively, transforming this into weeks, it's just a matter of multiplying by 7, 1 for each day, and we'll get 35 per week, and that's the equivalent of 5 per day. So now that we have this, we're going to go ahead and get the probability of the Poisson distribution here, where lambda is equal to 7 and the mu is equal to 35. And this puts us equivalently at e to the negative 35 multiplied by 35 to the 7, all of this divided by 7 factorial. Now I'm just going to skip the mathematics and get straight to the answer here. And the answer that we get is this. It's a very small probability, and equivalently, this is the percentage that we get. Moving on to the next part of the problem, we have the probability that more than 3 people show up in any consecutive day. So more than 3 people could be any number of people. It can go all the way up to infinity, theoretically speaking, though that's not possible. We have a finite number of people around the William Osler Center. The easier way to do it is to actually take the 100% and subtract the probability that no people show up, that 1 person shows up, that 2 people show up, or 3 people show up, because they're asking for 3 or more. So let's go ahead and adjust these numbers now, because remember that this rate, if you go and look up at the question again, is for any 2 consecutive days. So we need to adjust the mean yet again for each one of these. So for the probability of 0, we would have a mean that's equivalent to 10 per 2 days. And our lambda, of course, being 0 in 2 days. And this is true for p of 1, where the mu is still the same, and lambda is now 1 per 2 days. You can do this for 2 and 3 as well. And equivalently, I'm just going to plug that in now. So 1, which is the equivalent of 100%, minus e to the negative 10 times 10 to the power of 0, all of this over 0 factorial, and we're going to plug this in for p of 1 as well, so on and so forth, minus p of 2. So you're going to get all the values, you're going to plug them in. I'll show the last term as well, just to show a little bit of pattern here. I'm just skipping the bulk of the math to save time. And this would be 3 factorial. Equivalently, that would be this as follows. So remember, always check your math. Always make sure that you're doing these questions correctly. And if you don't truly understand what it is that you're doing in these questions, always question yourself, is this right? Is there a reason why I'm doing it this way? Because statistics is a very fussy kind of mathematics where every single thing that you do needs a good reason. Otherwise, your answer might end up being wrong. And we get a very high probability in this case that more than 3 people show up in 2 days. Because comparing it to the original mean of 5 per day, it's a very high chance that more than 3 people will show up in 2 days, right? So there you have it. If you have any questions, please feel free to comment.